students, today we will see one topic from matrices, that is eigenvalues and eigenvectors. Today we will cover this topic broadly. I will not only discuss an example about this, but also I will discuss step by step process how we can move further and learn this topic. So first of all, I will start with an example. For example, if you are given a question where a matrix is given, that is 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. So this matrix you are given and you are asked to find the eigenvalues and eigenvectors of this given matrix. So how we will proceed further? So I will tell you how to solve in just 3 steps. So first step is step 1. uh, First of all, this eigenvalue can be found by a minus lambda I into x is equal to 0. Here A is given matrix and lambda is a constant, I is identity matrix, and x is unknown matrix. So step 1 is to find this. So for this given example, let's find the step 1. So let's write step 1, so that can be written as a minus lambda I. First of all, let's write in this form 8 minus 6 2 minus 6 7 minus 4, then 2 minus 4 3. This is a minus lambda times identity. For 3 cross 2, for 3 cross 3, identity is this, into this whole is multiplied by x. X is x1 x2 x3, that is equal to 0. Here 0 is, it is null matrix. It's not just 0, for different dimension it has different values. So step 1 is to get a minus lambda I into x is equal to 0. Now step 2. Step 2 is get the value of a minus lambda I is equal to 0. Okay. So we will find its value. So it will be determinant of a minus lambda I. From the above equation we can get 8 minus lambda minus 6 2. Here there is no x. A minus lambda I is equal to 0. So for second row 6 7 minus lambda minus 4. For third row minus 4, here it will be 3 minus lambda. This whole is equal to 0. Its determinant is equal to 0, so we will not write in matrix form, we will just write its numerical value 0. So this was step 2. Now step 3. Step 3 is, this is the very important thing you should remember. We will get the value of this lambda cube minus lambda square plus minus determinant of A is equal to 0. So what will come here? Here for lambda square there will be, here it will be sum of diagonal elements. Sum of diagonal elements. Here it will come sum of diagonal minors. So you have to remember this thing. It's very important. Here it will be negative. Here it will be negative. At two places it's negative, and then this equation comes. So you have to remember this equation. It's very important equation. By this equation we will get the value of lambda, that is our eigenvalue. So let's solve this equation for our given example. So solving further, we get lambda cube minus sum of diagonal elements. For this equation, use main matrix. By this given, also you can directly find its determinant by taking first row, then second and third. But I am telling you the easy method how you can solve this. So we have to take the sum of diagonal elements. So what will be the sum of diagonal elements? It's 8 plus 7 plus 3. It's 8 plus 7 plus 3 into lambda square plus sum of diagonal minors. So we will take the diagonal minors. How we will find the diagonal minors is, first we will take by this term. So we get this, we have to find determinant of this. So what will be the first determinant? It will be 7 minus 4 minus 4 3. 7 minus 4 minus 4 3 plus second. What will be the second? Along diagonal. So it will be, second will be this. So it will be 8 2 2 3. So it will be 8 2 2 3 plus third. What will be third diagonal is this. So along this we will get this determinant 8 minus 6 minus 6 7. So it will be 8 minus 6 minus 6 7. Okay. Plus determinant of A is equal to 0. Okay. So side by side let's find determinant also, so that we can put it in A. So determinant of A is equal to 8 into this thing. So it will be 8 into 7 minus 4 minus 4 3. Second term will be negative minus 6 into that, I have we find determinant. I am finding it along the row. So it will be, for second it will be like this, minus 6 minus 4 2 3, minus 6 minus 4 2 3. Third will be positive, so it will be minus 6 7 2 4, minus 6 7 2 4. So solving this, we will get 8 into 21 minus 16. Here it will be plus 6, here it will be minus 18 plus 8 plus 2 into minus 24 minus 24. Here it's, for last term it minus 6 7. Here it's minus 4. So it will be 24 minus 14. So solving this we get 8 into 5 plus 6 into 10 plus 2 into 10, that is equal to 8 into 5 40 plus 60 here plus 20. Here we have done a mistake, it's minus 10, so here it will be minus, so we get 60 minus 60, that is equal to 0. So we got determinant of A is equal to 0. So here it is equal to 0. Now solving further above equation, we will get lambda cube minus 8 plus 7 plus 3, it will be 18, lambda square, then plus it will be 45, lambda is equal to 0. Solving this, you can solve this easily. Now solving this equation, we get this equation. Now solving further, we get lambda square minus 18 lambda plus 45 is equal to 0. Now we got a quadratic equation, and I think you know how to solve this equation. Taking its two factor, we have to take such a factor that its sum is 18, so it will be 15 into 3. Okay, so it will be lambda into lambda minus 3, lambda minus 15 is equal to 0. How I got this? You can try by 1, 2 and 3. By putting 3, we come to know that it is becoming 0. So with 3 it will be 15. So in this way we can find the value. So lambda is equal to 0, 3, 15. So we got 3 eigenvalues, 0, 3 and 15. This implies eigenvalues of given matrix. We got eigenvalues of given matrix. So let's see again how we did it. So first we were given matrix. This was the step 1. A minus lambda I into x is equal to 0. This was step 2. Find the determinant of A minus lambda I. For that we have got a very easy method how we do. Lambda cube minus this term into lambda square plus this into, here it will be a lambda is missing, here it will be lambda minus determinant of A is equal to 0. Okay, so further solving this, we got here, we found the determinant here, and then again solving that above equation, we got this term, and from here we got the eigenvalues. So this was the part 1 where we found the eigenvalues. This was part 1. Now we will find the part 2. Now part 2. In part 2 we will find eigenvectors. So what are eigenvectors? Let's take for a particular value lambda is equal to 3. For lambda is equal to 3, let's find eigenvector. In similar way you can find eigenvectors for 0 and 15 also. Okay, so what we will do here, it will be 8 minus 3. What we will do, we will put the lambda in this equation. Let's give it 1. How we will get? By 1. We got 8 minus 3. Then minus 6 2. Minus 6 2. For row 2 we get minus 6 7 minus 3 minus 4. Minus 6 7 minus 3 minus 4. And for third row 2 minus 4 3 minus 3. 2 minus 4 3 minus 3. Solving this, we get, here it will be x1 x2 x3. is equal to 0, 0, 0. Why we did this? Because this was our step 1. Okay, this was this one. This we are going to use it. Okay, and here this will be our eigenvector, so we have to find the value of x1, x2 and x3. So solving this, we get here 5 minus 6 2 minus 6 4 minus 4 2 minus 4 3 minus 3 0 into x1 x2 x3 is equal to 0 0 0. So we got these values. Now we have to find the value of x1 x2 and x3. So for that we will solve this. We get equations. We will get three equations. 5x1 minus 6x2 plus 2x3 is equal to 0. Minus 6x1 plus 4x2 minus 4x3 is equal to 0. And third will be 2x1 minus 4x2 plus 0x3 is equal to 0. So we got these three equation, and from these three equation we have to find the value of x1, x2 and x3. Now we will use Cramer's rule to solve the equations. Okay, so according to Cramer's rule it will be x1 minus x2 x3. Now let's take two rows. Let's take this one and this one. Okay, so first of all we will hide the first one like this. We will hide this and we will take the determinant of this thing. Okay, so it will be minus 6 2 4 minus 4. Similarly for second we will hide second and we will write determinant of the rest terms. For x3 it will be 5 6 minus 6 4. Okay, solving this we get x1 upon determinant of this will be 24 minus 8, it will be 16. Second will be minus 20 plus 12, it will be 8. And third will be 20 minus 36, it will be minus 16. Okay, so from here we got x1 x2 x3 is equal to 16 8 minus 16. Simplifying it further, taking common out as 16, we get, let's common out 8. Okay, so we get it will be 2 1 minus 2. So this is our eigenvector. This is one of our eigenvector. So in similar way, you can find other two eigenvectors by other two values of lambda. So in this way, we got this is one of the eigenvector, and similarly solving further for rest two values you can find it, and I am giving the answers. It will be for lambda is equal to 0, it will be 1 2 3. For lambda is equal to 3, that we have already found is 2 1 minus 2. For lambda is equal to 15, it will be 2 minus 2 1. So these are our three eigenvectors that we have got. I hope you have understood. If you have any query, then you can let me know. Thank you.